Hello, welcome. Today let's try to solve a Leetcode problem 191, number of 1 bits. So actually this is the Hamming weight. It means the number of 1 bit. Yeah. So we are giving a number n. This n is a binary number, as you can see, and we want to count the number of 1 bit. Yeah. So we can directly use the Python library. So we can use n.bit count. So this bit count is used to count how many ones. Yeah. Now let me run it to check if it works. Yeah, as you can see, it works. Now let me submit it. And for this one, the time complexity is 32, because this is a 32-bit integer. But actually, we can optimize this solution because there's a follow-up. So if this function is called many times, how would you optimize it? So yeah, because this is a binary number, and for the binary number, there's some tricks about the bit manipulation. For example, if we have let's say if we have a number of 11 xxx. Yeah, and for this number, if we are going to use a bit count, normally this will be okay. K is 32. Yeah, 32 is for a 32-bit integer. Yeah, because we are giving the input binary string would be length 32. Yeah, if we were to optimize, so how can we do? Actually, there's a trick for the bit manipulation, that is a and a minus 1. So this means if we are giving a number, it is 11xxx, and if this number minus 1, this means it will end a number. It will be 1, 0 with some numbers. So for example, yeah, with some numbers, it will be like this. So this means after one add operation, so this 1 will be reduced by 1. Yeah. So let me give you some example. So we're gonna first check the low bit of 1. So for example, this is starting from 11000. It's like this. So the low bit is this one. So this number minus 1, it's gonna become 10111. If this number add this number, so what's the result? So it's gonna be 1 0 0 and 0. Yeah, so this is one operation. This means we've already reduced by 1. Yeah. Now we are going to do the next operation. So for this number, we're gonna find the low bit of this one. It is still this number. And this number minus 1 is gonna become 0 1 1 1 1. And this end will become 0. So this means there are two operations for the n for the a and a minus 1. And as we can see, this number, there are 2 ones. Yeah. So for other examples, it's always be the same. For example, we have some numbers like this. Yeah. So we're gonna first find this low bit. So it is 1. Yeah. So if this number minus 1, what it becomes? So it becomes 111 0 0 0. So after the operation, it will become 1 1 1 and 0 0. Yeah, as you can see, before there are 4 ones. After the operation, it becomes 3 ones. And how many operations we can count? There are only 4 operations because inside there are 4 ones. So this is some trick you need to basically remember, and you need to try to understand why we can use this a and a minus 1 to count bit 1. Yeah, because according to the low bit operation, after that it will always become 0, like these areas and these areas always become 0, and the 1 reduced. The number of ones reduced by 1. Yeah. Now let's try to use this method to solve the problem. Yeah. So for the low bit operation, we're gonna I will prepare a result. So while this number exists, I will do the low bit operation. So the result would plus by 1 because this n is more than 0 up to now, and this n should be updated to, so this n should be updated to n and n minus 1. Finally, what we're going to do, we just need to return the result. Like this. So the n will be updated to n and n minus 1. Now let me run it to check if it works. As you can see, it also works. Now let me submit it to check if it can pass all the testing cases. And by the way, the time complexity is, let's say, OM. M is the number of ones. As you can see, the time complexity has already been decreased. Before it is 32. After that, it is much smaller than 32. It is dependent on how many ones inside the binary representation of